Here is some practice with expanded notation. Here we are asked to write each number in expanded notation. So we look at each of those digits and we think about what they're worth. That 4 is worth 4 million. So we write 4 million in there, and then we put a plus sign. Next digit is worth 700,000. Then we have 1,000. And finally, we have 600 plus 2. Looking at that next number, that first digit 3 is worth 30 million. The next digit is worth 9 million. So we write that out. Whoops. You'll notice for any digit that there's a 0 there, I do not put anything. This 2 is only worth 2,000, so I write that in, plus 2,000. And finally, in the ones period, I have 178. One way to check these is to look to see how many digits and how many addends that is, how many digits are in your number that are not 0, and then how many addends those should be how many addends that you have within your number. So there are 1, 2, 3, 4, 5, 6 digits that are not zeros. So I should have 6 addends with my expanded notation. 1, 2, 3, 4, 5, 6. That is correct, just as this number was 1, 2, 3, 4, and 5. I'll show you another way with that last number to look again to check. So we'll start at 900 million. Careful with the number of zeros that you place there. Then it's 6 million. Plus 10 plus 8. Alright, the other way that I was going to say that you could check this is to look, hey, the 9 should be worth 900 million in that number. Yep. 6 should be worth 6 million. Yep. 1 should be worth 10, and 8 should be worth 8. 4 addends, 4 digits that were not 0. 906 million, 18. Here we're asked to write the number in standard form. So we go period by period. Let's go with the millions period first. This is the only addend that deals with the millions place. So for that, we just write a 7 in the millions period. These two addends have to do with the thousands place, 50,000, 8,000. So we write a 0 as a placeholder, so that 5 within that number will be worth 50,000, and that 8 is worth 8,000. For these last two addends, in the expanded notation that we're now asked to write in standard form, what would you end up writing here? We would write 049. We look at our number that we've written in standard form. You read it to yourself. It says 7,058,049. And you look at it and really make sure it has the right number of digits within each of those periods. 3 there in the ones period, 3 there in the thousands period, and 1 digit in the millions period is fine as long as there are not any other periods that we're thinking of. For the next number, that is done much the same way. Starting in the millions period, we're working with these two addends here. So that's 703 million. Next, we only have one of these addends that works within the thousands period. That's why we write 100,000 there. And finally, for 62, 60 plus 2, we write a 0, 6, 2. Each of these digits should be worth, and value-wise, 2, 2. 6 up would be worth 60. Yep, that's there. This 1, okay, it is in the 100,000s place. It is worth 100,000. That's why that's there. 3 million. Yep, matches up. 700 million. matches up. A number looks like it's written correctly, standard form-wise, where there's 3 digits in each of those periods. Here are 2 more problems where we are asked to write the number in standard form. There's a difference with these 2 problems and the previous problems in that these are no longer in order. In order meaning that the biggest number is not first. The biggest number is the 2 million number. We can still work at this in much the similar manner that we worked with the other ones. We'll start with the largest place first. And then so I worked with that end already. And then we can go to the thousands period. And then so we have the 600,000, the 40,000, and the 9,000. So the digits would be 6, and then 4, and then 9. And finally we have 52, and that is written as a 0, 5, 2. The other way that we could do this is that we could rewrite the problem so that the largest addend is first, and then to write it all out completely, just to take that one extra step. If that's what's going to help us solve this problem properly, then we could take that extra step to really show our work, and to just, this is something that we are more familiar with because this is the same thing that we saw on the previous screen. And again, it's that same way, 9, 0, 5 in this particular case. And then so we have 87,000, 0, 8, 7, 20. What would you write in that last period? Hopefully you remembered the 0, 0, 2, 0. Reading our number, 905,087,020. 3 digits, 3 digits, 3 digits. 900 million, 5 million, 80,000, 7,000, 20. If you're still continuing to have difficulty, or as you're learning, and as you're thinking about this, you could end up using a place value chart. So you place that number into a place values chart so you really think about those values for each of those digits. So the value for this first digit is, since it's in the 100 millions place, is worth 500 million. And then so we would write 500 million there for our expanded notation. The next digit, since it's in the 10 millions place, is worth 70 million. The next digit would be worth 6 million. And then the next digit would be worth what? Right, 200,000, because it is in the 100,000s place. You'll notice again that since this is a 0, we do not write any digits. For 5, this is in the thousands place, so it is worth 5,000. And then you would write 70, and then you would write 8. 1, 2, 3, 4, 5, 6, 7 digits that are not 0. So we should have 7 addends, 500 million, 70 million, 6 million, 200,000, 5,000, 70, 8. Again, a place value chart. And in this case, could you make a place value chart? Yes. The ones period, thousands period, millions period. Expanded notation.